with the beautiful work that you guys did earlier. You guys did a lot more work than I was planning on doing today. I'm actually thankful the network was down. Because you got into some stuff today, in particular those threes that Austin and Nathan were talking about. In particular, those threes were something I was going to bring up next week with my chicken flock, which we'll now get to next week, and that's totally fine. Totally fine. So the idea now is, this is how I was originally going to do it. And what this does is, it rolls 3 dice. Here are the 3 dice. Every time I press F9, it rolls 3 dice again, and it keeps track. Now, when I set this up, I was betting on 5s and not 4s. I hope you guys can live with that and realize it doesn't matter what number you bet on. The probabilities are exactly the same when you bet on 5s, 4s, or 3s, or anything. So, what I want to keep track of here, actually, this would be a good one for us, 2 4s. That would have won us $1. But we're betting on 5s, which means we get squat. This number right here keeps track of how many 5s show up. That graph keeps track of the cumulative probabilities of the results. So this would be the same as you walking in there with a pocket full of money, putting it down and betting over and over and over again and keeping track of what happens, assuming the dice are fair. So I'm going to press F9 and roll. Here we go. There we go. Again, no rolls there. No, none there, none there. Okay, right there. Boom, we hit 2. We hit 2. We hit 1 there, 1 there, 1 there, 1 there, 0. This is getting old. Let's just hold down the thing. I'm going to keep track. What I want you to do is look at these numbers right here. Where are they dancing predominantly?
0 and 1.
They're dancing around 0 and 1. Now, why are they dancing around? You know the answer to this already. You figured it out. 200 out of 216 times, they're going to be dancing around 0 and 1 on average, right? That's not very good. That means on average, 200 out of 216 times, you're losing 50 cents, right?
Yeah.
You're losing 50 cents on average. Now, the average of the entire game has to be a little better than that. Because the other 16 out of 216, you're making money. And this is simulating that right now. Look at those. Did we hit any 3s yet? We did. It happened 4 times so far. We hit 3 5s 4 times. Watch it. Every once in a blue moon, you'll see a 1 show up right there. Is that this one?
Yes.
I blinked. See, you can't blink in this damn game. It must have happened right away.
It did.
It did, right? I mean, and that's the thing. Somebody brought the little old lady from Pasadena in the last class, sitting there waiting for her to hit on the machine. You can do that all day long, but it doesn't guarantee when it's going to happen. I'm not looking. Sam, I missed another one! Now, but watch. We would expect one of those every 216, right? We've hit 7 times out of 1,264. That's about right, isn't it? It's actually, right, exactly, but it's about right. Every 200 times-ish, we should be hitting.
Yeah, that's about right.
So we should get about, right now we should have about 6, we're at 7. So we're actually hitting close to what we should. But remember how 2 of them came right away at each other? It's not a guarantee of when it'll happen, it's a guarantee that it will happen over time. That's why that one question was so important, is the overtime. Over time. You might lose 5 hard discs this year and 5 hard discs next year. But that will be a freak little anomaly within the overriding system of the distribution. So go on, look. Are you seeing our numbers show up? Has anybody calculated the actual percentages those things are, the 125 out of 216? I'm going to let this thing play. I'm going to let this thing play for a while. While it's playing and doing its thing, it's starting to look about right. I mean, it should look exponential like that. Let's calculate our average losses. We know it's around negative 50 cents, correct? Based on what we just analyzed. Let's feed it through our TI and find out what it should be. And I'm going to let this thing think while we're doing that. Steeper. Pretty steeper. Good. Let it do its thing. We'll come back to it. I'm going to swing the camera over here. Grab your TIs. Please, Rory.
So the actuary's job is just to kind of run that, and then, but how do they decide like when it's like morally wrong? Like,
Well,
is there like somebody who oversees actuaries?
yes, and they're the ones that you have to question. Yeah, the actuaries are, and this is not me speaking as
Actuaries
such.
are hired by the casino.
Actuaries are hired by life insurance. They're hired by the casinos. The casinos actually have their own actuaries sometimes. Their job is to, I have this vision of what happens in a casino with actuaries, of the actuary coming in, sir, I have to report, sir.
Yeah.
You know, and they hand out, oh, thanks, Mikey, that was great, have a good day. They smack him on the butt and give him a Snickers bar, and he walks out the door, and then the door closes, and then the crap happens behind the door. That's the vision I have. Sorry, YouTube world. but that's what I envision, right? Like actuaries are purists. They know they can't affect the probabilities at all. They are off limits. You can't touch those. But they know they can adjust the payouts. That's what you have control over. So Caitlin, again, that's why I made the big deal about when you said that 90 and you split it 2 to 1. That's only a function of how they set the payouts. There's no mathematical tie. It was a great idea. It was a fantastic idea. There's no reason not to do that. The actuary can say, you know what, let's make it 2 to 1 and see what happens. That might be your quiz next week. Make it 2 to 1 and see what happens. But the idea is they can play with those numbers all day long and see what pops out, knowing they can't control the P and X column, but they can control the X column.
So the actuary's job isn't to like balance it and be like, okay, we've got to keep people coming in, so I got to make it pay out once in a while.
That's kind of where the actuary and the casino owner work hand in hand. Because the casino owner very often has psychological data.
Yeah.
Like if I make the payout 20 to 1.
Nobody goes to the table.
Exactly. What if I make it 30 to 1 or 40 to 1? Can I still make money? Actuary, dude, can I still make money? Yes, sir.
Yeah, just like add another dice. Like, why don't they just play Yahtzee and
Exactly. Then it does get a little too complex.
Yeah.
The beauty of this game is it's pretty simplistic, even more so than craps. Craps has 2 dice, but the betting rules are off the charts, crazy to follow. But it goes very quickly. And even if you don't know what you're doing, you can lose money very rapidly, because it's usually giving you free drinks while you're doing it too. Rory, that's a fantastic question. The ethics I can't get into too much, except what my envision is. But actuaries are the ones that actually figure this, and what you're about to do, that's what they do too. You guys got an average? Let's run it. This is just like last time. Run through one of ours. It's a weighted average, yes? It's a weighted average, just like before. Let's run this bad boy. Let's get these numbers out of there. So our payouts are -1, 0, 1, and 9. Whoops, no 2. I hit the wrong button. 9. So this is Rory. They have software that does this, and you do too. It's called Excel. I'll have you do quizzes with that too eventually. They can change that 9 to a 19 and explore what a 20 to 1 payout looks like. And then they can figure the average on that and say, oh, we still make money, just not as much, but it might be worth it if we can pull more people into play. And that's the balance game that the owner plus the actuary actually does. Thank you, sir. Here we go. 125 out of 216, about 58%. 75 out of 216, 38%, about 7%, and this is pretty lame, about 0.5%. I'm just curious. I'm going to turn Excel back on. Let's see how we're doing.
So when we get an average here, does that mean?
Hold that thought, because understanding the average is the most important part of this whole problem. Okay, here's what Excel is telling us it should be. 57.5%. What does ours say? 57.8, 10.9. Not bad. 34.9, 34.7. 7, just a tad under 7. 0.005,
A little high.
little smidge high. But again, that evens. Let's leave it up there. Let it even more. I like the idea of let this. And then we've gone out. We've played about 10,000 games now. So the question is, we've played 10,000 games. We walked in with 10,000 $1 bills in our pocket.
We're getting screwed.
What are we walking out with? Let's find out. Let's find out. We can now answer that. What are we walking out with? That's what this is going to tell us. You guys ready? We got this? The math is done. You did the hardest part, yes? Now it's just one of our stats. Stat count, 1 var, L1, L2. We're recording, yes. Let's get a zoom in on this. Uh-huh. There we go. The average is the very first number given. They call it X bar. It's actually mu. It should be mu because this is actually a population distribution. This is what happened for you guys. So you bet $1. On average, what happens? You lose half of it. That's what that says. You lose about 47 cents. So in other words, if you walked in with 10,000 and you played exactly 10,000 games, you're going to walk out with half of it, $5,000, right? You're walking out with half of that, assuming you stopped. But the problem is if you had 5,000 left, you probably keep playing, and then after 5,000 games, you have 2,500 left. After 2,500, you'd have 1,250 left, and then 625 left, and then eventually you're like, I got no money left, but I've been here for 3.5 years. That's the idea. The idea is eventually you'll stop because they'll get so drunk you'll pass out unless you leave. But the idea is, the fact that it's negative is genius. Because essentially you're not doing this. You're not walking up giving the little I almost call him the bartender, the dealer. You're not giving the dealer $1 and playing the game. You're essentially walking up and handing him 47 cents and walking away.
Yeah.
Right? That's what that means. You're walking up, handing him 47 cents, have a nice day, and walk away. And you're keeping 50, whatever, that's 53 cents of your own. But you've just donated half of it to the casino, to which they apply to their power bill and their water bill and their free drinks they give you for the big games, yes?
I feel like a lot of gambling addicts would have been prevented if they have taken this class.
You know what they'll always say?
No.
You know what they'll always say? But all I've got to do is hit the big one. They'll always say that. And the thing is, Lauren, I love what you're saying. I love the fact that you're saying that, but there's a level of logic that escapes most people.
But I could never.
You can't explain that to people. Well, first of all, like the .0049, which is, it's now starting to correct if you see that it's coming down below the .005 now. But that's the part people don't fully understand. Yeah, all you've got to do is hit the big payout. The problem is it's going to cost you $216 to win 9. That's the problem. If you could somehow make them understand that,
Yeah, but that doesn't, I mean.
it clicks to you guys because you're programmed to think that way now. Bless you all. You're now programmed to think that way. That's the beauty of it. But how many people have sat in this class?
That's what I'm saying.
Right, exactly.
First,
Well, I told you about the cartoon, right? The Vegas cartoon?
Yeah.
Generously paid for?
Yeah.
Yeah, that's the point. If people knew this and believed it. Now, sometimes, I'm not saying don't gamble. Please realize this. I'm saying know what's going to happen. Right? Don't go in there. And I love the fact that Oregon was the first state I ever noticed that put at the bottom of all their lottery billboards, not to be used for investment purposes. As if anybody would. But that's the thing. That shows a level of unfamiliarity with mathematics and statistics in this particular case. A level of unfamiliarity. Like, you can't say, I'm betting the house on this Powerball ticket.
Oh my gosh.
I mean, yeah, maybe you walk up to the table and you take all 10,000 bucks and you put it down and go, 4! And you bet on 4. And you bet, ready? We bet on 4. Bet the vote. $10,000 on 4.
Thanks.
We just got it all back. Do you now walk out?
Yes.
Yes.
Are you sure?
Yes.
Have you seen people gamble?
Yes.
Yeah, Nathan, see what Nathan did? Oh shit, thank God. We had a 1 in 3 chance of that happening, right? Roughly? What is it now? 34%. We had a 1 in 3 chance of that happening. Thank God we hit the 1 up 2. Yes, exactly.
Go again.
Go, walk out of the casino. You should have walked in the first place. Hot and bothered up here. But that is the idea, is that you can't explain that to people if they don't want to see it.
Yeah. Look.
You now see it. You guys get it. That it's going to cost $216 to win 9. You realize it's a losing proposition. But I had a student in the last class said, my uncle walked into Chinook Wins. You put $5 on one of the one-armed bandits, boom, and he hit it. He walked out with $1,000. That's awesome. How about the guy that came in after him and saw him do that and tried it? How about the guy after him? How about the guy right before him? And he's like, I don't know. I'm like, exactly. Because your uncle was that. It does happen. We just saw it happen twice in a row, didn't we? It does happen. And if you happened to be playing right then, you would have bet $3. You would have lost 3, right? Would have won back 18. And you'd be like, gambling's awesome. Until you keep doing it and realize you're just part of this distribution. Thank you for the comments. Wonderful comments. Rory, go ahead.
But it's still professional, like, poker players.
Poker's different. How?
Because it's a game of
Other
skill,
people?
not luck.
Poker is a game of skill, not luck. This is pure chance.
Yeah.
You do not control this at all.
But you don't control the cards either.
No,
They're
but
But how
you
you use them.
That's true.
There is a level of skill. Austin's nailed it. There is a level of skill involved in poker. The only random part of poker is when the cards first come out. Anytime the card leaves the deck and goes to a
But you
person.
still have the ante in, so that's chance. Your first.
Yes, but the poker players know.
They can, fold.
They know the blinds. They know what they can see on the table. They know the likelihood. If I'm holding this, what's the? There was a great movie that I never saw. I saw the preview for it. Matt Damon was in it. This is going back about 10.
Oh, it's
You remember what I'm talking
I
about?
know what you're talking about. I can't think.
There's a great scene. Matt Damon, he's very young in this movie. He walks into a poker game in progress, and he makes some kind of a comment about what's going on the table. And how would you possibly know that? And then he begins to Rain Man out what all the guys have in their hands. You know, Professor had that because he showed it on the 3rd round, then he pulled it back, and blah blah blah. And people are just like, what the hell? Card counting is one way of winning at poker by figuring out what people can and can't have.
They're called rounders.
Yes.
That's it. Rounder. I never saw the movie, but that scene makes me want to watch it just because of that scene. But the thing about poker is it's different than this. This is pure chance. You'll never see me analyze poker in this class, or blackjack, or what are some other ones? Blackjack, poker. They're coming to mind right now. You'll see me analyze the roulette wheel. You'll see me analyze craps. You'll see me analyze this, which is called chuck-a-luck, because those are pure chance. You can control the probabilities in poker, because if you're skilled, you can make them in your favor, to some degree, Not to 100%, but way better than, obviously, 75%. Good. Thank you, Rory, about poker. Thank you for that comparison. That was very, very good. Lauren?
So, counting cards.
I can't do it. It's too much going on at
My
once. I'm too
grandpa
ADD.
used to
You can
do
do it?
which is
Rain Man, exactly. Yeah, counting cards is a wonderful thing. I'm way too ADD
So
to do it.
that obviously would increase your probability
Yes.
significantly.
Because the sample space goes down with every card you count. As soon as you see that you have an ace in your hand, you know there's only 3 left in the deck somewhere. So you know that. This is what happened. The movie 21, which some of you may have seen. The book, if you get a chance, read the book, Bring It Down the House, that's what it's based off of. They changed the way Vegas deals blackjack because of those kids.
Yeah.
They used to just throw all the cards in a horseshoe, 6 decks in a horseshoe, and deal from that. But the kids took full advantage of that, because then you don't know, once you see an ace, there's only 3 left in the deck.
Yeah.
Once you see an ace, there's 6 decks worth of aces in there, -1. And the idea that they're clumped together actually goes way the hell up. In other words, you put 6 decks together and shuffle them up, there's almost no chance it's 1 deck, 1 deck, 1 deck, 1 deck, 1 deck, 1 deck. It's all mixed together. So you could have a run of 6 aces in a row, and the chance is pretty damn good that there's somewhere in there over time. Those kids took full advantage of this long run average plus that idea. Good stuff. Good book. Very little, the mathematics is even easier than this, believe it or not. But the idea is if you can capitalize on the likelihood when the odds are in your favor, you can make a buttload of money. And that's what's cool about that book and that movie too. The movie was pretty good. But the book is, I think, good? Good questions. Thank you for all the questions and comments. I got one last thing I want us to do today, and that's to analyze life insurance, which is a gamble. For both you, obviously, because you want to stay alive,